on example 3, we're going to be doing the same thing, but it's going to be a little bit different. Because what does example 3 not give us? It does not give us the slope. So we still want to write this line in point slope form. We want to write the line in the form y minus y1 is equal to m times x minus x1. We have two different points that we could choose from. It does not matter which point we choose from to write the equation of the line. I'll write the answer using both. But we need m. We do not have the slope to this line. So I'm going to go find the slope for this line. I don't know what's wrong with this thing sometimes. And in order to find that slope, we're going to be using the slope formula. So I'm going to use the slope formula to find m. And the slope formula says that m is equal to y2 minus y1 over x2 minus x1. It doesn't matter which point we choose as y1, y2, x1, x2. That's perfectly. It doesn't matter as long as we're consistent. I'll name this x1, y1, and I'll call the second point x2, y2. So I'm going to apply this formula to find the slope. So I have 1 plus 4, because I'm subtracting a negative 4, over negative 2 plus 1, because I'm subtracting a negative 1, which gives me 5 over negative 1, which gives me a slope of negative 5. So now that I know the slope is negative 5, I can write the line in point slope form by filling this out. So let's say I choose to use the first point, then I would have y minus y1. y1 would have been a negative 4, so if I'm doing minus negative 4, it would turn into a plus 4, is equal to m, which we calculated as negative 5, times x minus x1. x1 would be a negative 1, so that would turn into x plus 1. This is the line in point slope form. If I had chosen to use this point to write the line in point slope form, then my equation would look like y minus y1, which would be a minus 1, is equal to m, which is still negative 5, times x minus x1. I'm saying x1, but it doesn't. I'm talking about the blue x point, okay? Which is a negative 2. Since I'm subtracting that negative 2, it would turn into a plus 2. So either one of these answers is correct for the point slope form. If you think about it, there's infinitely many ways to write a line in point slope form because there's infinitely many different points that I could have chosen to plug into the equation. Doesn't matter which one we use. So now that we have that line written in point slope form, let's graph it, and then we'll also write the line in slope intercept form. So to graph the line, it'll be super easy. I'm actually just going to plot these 2 points. We could have done this from the start. Just plot negative 1, negative 4, and plot negative 2, 1, and connect those points. And there is the line. It's graphed. Great. Now I'm going to write the line in slope intercept form. To write the line in slope intercept form, all we have to do is solve for y. So it doesn't matter if we take the version of the line with the purple point, or if we took the version of the line with the blue point. If we solve for y, we should get the same thing on both sides because these are supposed to be the exact same line, just written differently. So in both of these, I'm going to just distribute the negative 5 first to give me a negative 5x minus 5. I'll do one at a time to get the negative 5x minus 5. And now I still haven't solved for y yet, so I'm going to subtract 4 from both sides, which gives me that y is equal to negative 5x minus 9. Now that should be the line in slope intercept form. It looks pretty good because I can see that it has a y-intercept of negative 9, and it does look like this line would be hitting the y-axis around there. Let's go see what we get when we manipulate the second version of the equation. I'm going to start off the same way by distributing that negative 5 to give me a negative 5x minus 10, and then I'll come in and add 1 to both sides of this equation to give me y is equal to negative 5x minus 9, which is the exact same thing that we got on the first side. So good. And this is our line in slope-intercept form. I have to think about these names so I don't mess them up in the videos. Okay, let's look at example 4. The line passes through 2, 3. First, let me just plot that point. There's the point 2, 3. And the slope is undefined. Slope is undefined. We have to think about, well, what does that line look like? Is it vertical or is it horizontal? Let's refresh our memories by going back to lesson 5. Lines that have undefined slope are vertical. Undefined slope or vertical lines. We saw examples of that in example 7 and example 2 from lesson 5. So I know that the line looks like this. Slope is undefined. That means that it is a vertical line. Okay. Vertical lines always have the form x equals some number. In this case, that number is 2. There's no way to write this in slope-intercept form because we can't solve for y. There is no y in this equation, so I think in the directions it even says write the answer in slope-intercept form if possible. You can't possibly write a line in slope-intercept form if there is no y in the equation. Similarly, there's no way to really write this in point-slope form because the equation is simply x equals 2. There's nothing else we can really do about that there. So I don't want you to think that every single possible line you can write in every single form. That's not always the case.